So this problem is based on the impulse response. Determine the impulse response of DT-LTI system in terms of unit impulse input delta n for Hn is equal to 2 raised to minus n un minus 2 raised to minus n u of n minus 3. So first we write the given expression. So given that h of n is equal to 2 raised to minus n u of n minus 2 raised to minus n u of n minus 3. So we have to express Hn in terms of unit impulse response. So we write here express h of n in terms of unit impulse response. Unit impulse response delta of n. So h of n is equal to 2 raised to minus n. We take outside 2 raised to minus n outside the bracket as a common value, u of n minus u of n minus 3. So the sequence u of n minus u of n minus 3 can be written as u of n minus u of n minus 3 is equal to as we represent this as a unit impulse response. Since here every sample is having unity magnitude. So we can write the expression as u of n minus u of n minus 3 is equal to, this is 1 1 1, that is equal to delta of n plus delta of n minus 1 plus delta of n minus 2. Three values having unity magnitude. So we can write h of n is equal to 2 raised to minus n into delta of n plus delta of n minus 1 plus delta of n minus 2, and we multiply this 2 raised to n minus 1 in bracket. So Hn is equal to 2 raised to minus n delta of n plus 2 raised to minus n delta of n minus 1 plus 2 raised to minus n delta of n minus 2. This is the expression. So it gives the impulse response of delta n. Next point is invertible system and deconvolution. So first we will see what is invertibility of the LTI system. So a system is said to be invertible if input of the system can be recovered from the output of the system. So we can write here system is said to be invertible if input of system can be recovered from output of system. So block diagram for this is, suppose Xn is the input, it is given to the block, So here input is xn, output is also xn, but output of the first block is yn, which is given to again the invertible system. So we get the original input. So here h represent the discrete time signal system. What is h? It represent discrete time system, and it produces which signal? Y of n, when xn is input, and this y of n is applied to the second system. This is also a discrete system. Y of n is applied to second system, and this is also which? Discrete time system, and it is denoted by h raised to minus 1. So this h raised to minus 1 denotes inverse operation. It denotes inverse operation. So we can write equation y of n is equal to h of x of n. Y of n is output of the first system, so it is h of x of n, and we can write h inverse of y of n is equal to h inverse of y of n is equal to, we can write this equation as h inverse of y of n is h of x of n. So we can write here h into h inverse into x of n, but we know that h into h inverse is what? 1. So h inverse of y of n is equal to x of n. So here h inverse, h raised to minus 1, it is the inverse operator, and it is associated called as an inverse system. So we see the problem related to this. So this is the problem. Which of the following systems are invertible, and if invertible, then find the inverse. So we will see the first problem, that is y of t is equal to x of t raised to t minus 1. So first, what is given equation? Given equation is y of t is equal to x of t minus n. So x of t, it is the signal, and it is delayed by n sample. So we write here signal x of t is delayed by how many samples? By n samples. As it is delayed, so it is invertible system. So it is invertible. So it is invertible system. So we can design another system x of t, and it can be made advanced by n samples. So this system is invertible, and we design here another system, and it can be made advanced by the n samples. So the system is y, as it is advanced, it is y of t plus n. So we can draw this as, this is system 1, input is x of t, this is inverse system, x of t, output of this is x of t minus n. This is inverse system. We denote it by z of n or z of t, that is equal to x of t minus n plus n, that is equal to x of t. Now the next problem is, what is given? Given is y of t is equal to x of 2t. So the input is x of t, and the system indicate output is obtained by compressing the input by value 2 or factor 2. So here input is x of t, and what is that 2? This 2 means the system indicates that output is obtained by compressing the input by factor 2. So the basic system is x of t, and this 2 is nothing but it is compressed by the factor 2. So the another system will expand the input by 2. To get the original input, again we have to expand it. So there can be another system which will expand input by 2 to get the original system, or to get the original input. Thus it is invertible system. And its inverse is z of t is equal to y of t by 2. So we draw here the diagram. System input to this is x of t, output is x of 2t. It is given to the next system. So this is z of n, that is equal to x of 2t divided by 2, that is original system. Now the third problem, that is what is given is y of n is equal to n into x of n. So this indicates that x of n is xn is the original system, and it is multiplied by the n. So to get the original system at the output, we have to divide it by n. So it indicates input x of n is multiplied by n, and we can design the system which will divide input by n. So this is invertible system. So it can be denoted by Zn is equal to 1 by n y of n. So the diagram is this is n into x of n, and we want original input as the output. So z of n is equal to 1 by n into x of n. So that is equal to x of n.